You are watching AliAziz Quality Education YouTube channel.
Engineering Mathematics in BSc Aircraft Maintenance Engineering Technology, AMET. By AliAziz Quality Education.
AliAziz Quality Education channel, providing you the aviation industry related videos. So don't forget the subscription button.
Engineering Mathematics is a core subject in the AMET program. It equips students with essential mathematical tools needed to understand and solve real-world problems in aircraft maintenance, repair, and overhaul (MRO) operations. From the design of aircraft components to performance monitoring, math is embedded in every technical aspect of aviation. Why it matters in aviation. Aircraft systems are complex, and their safety and efficiency rely on precise calculations. Engineering mathematics supports structural integrity assessments, helps analyze aerodynamics and fluid flow, aids in diagnostics and predictive maintenance, is used in compliance with international aviation standards. Key topics and applications. Mathematics topic. Application in AMET. Algebra. Used in unit conversions, force and motion equations. Trigonometry. Crucial for angles and distances in navigation, radar systems, and airframe analysis. Calculus, differentiation and integration. Applied in fluid dynamics, fuel flow analysis, thermal calculations. Differential equations. Models engine behavior, vibration analysis, and flight dynamics. Linear algebra and matrices. Used in simulations, electrical systems, and control engineering. Statistics and probability. Essential for reliability engineering, failure rate predictions, and quality assurance. Complex numbers. Important in AC circuit analysis and wave mechanics. Real-world applications in AMET. Aircraft weight and balance calculations. Ensuring an aircraft is within safe operating limits. Stress and strain analysis. Calculating forces acting on aircraft materials and structures. Electrical circuit analysis. Using Ohm's law, Kirchhoff's laws, and Laplace transforms. Fluid mechanics. Applied to fuel systems, hydraulics, and aerodynamics. Thermodynamics and heat transfer. Used in engine performance, vac systems, and fire safety. Navigation and avionics. Involves vector mathematics and coordinate geometry. Skill development through math. Analytical thinking. Logical problem solving. Interpretation of technical data. Use of engineering software like MATLAB or AutoCAD. Compliance with EASA/CAA/ICAO maintenance regulations. Career impact. Graduates with a strong grasp of engineering mathematics are better prepared for roles such as Licensed Aircraft Maintenance Engineer, LAME, Systems Analyst for Airlines, Maintenance Planner, Aviation Safety Officer, Technical Instructor or Trainer. Conclusion. Engineering mathematics is the language of aviation engineering. Mastery of this subject helps future aircraft maintenance engineers ensure aircraft safety, performance optimization, compliance with international standards, a successful career in the aviation industry. Whether it's calculating engine efficiency or analyzing sensor data, engineering mathematics forms the foundation of decision-making and innovation in aircraft maintenance engineering technology.